Welcome students. Now in this video we are going to see some of the numericals on this electrodischarge machining. So dear students, let us discuss the next question on this electrochemical machining. See what is given. In ECM operation with the flat surfaces, a 10 volt DC supply is used. The conductivity of electrolyte is 0.2 ohm inverse second inverse and feed rate of 1 millimeter per minute is used. The workpiece of pure iron and the properties for that iron is given, density, valency and gram atomic weight is given. Calculate the equilibrium gap. Okay, and ore voltage we have to consider to be 1.5 volt. Let us solve this. So we know that the equation of dynamics for the ECM we have already derived, that is this feed rate or change in gap, this dy by dt is equal to lambda by y, isn't it, minus this feed. So here as we are going to find this equilibrium gap, if this gap equilibrium, that is this y will be replaced by y e, and this change in this gap per unit time will be 0. So what will be our equation? That is lambda over ye is equal to f, or ye is equal to lambda divided by f. What is our lambda? We know what is our lambda, that is k into a into v minus delta v divided by rho f z. This is our lambda, we know this, into this feed rate f. Okay, so I hope this conductivity is given, the gram atomic weight A is given, supply voltage, ore voltage, density, Faraday's constant we know, valence is given, feed rate is given. So definitely we can able to calculate this equilibrium gap ye, which is equal to, put the values, ye is equal to, k is how much, 0.2, and as I taught you, please use the CGS unit for solving the questions on ECM, because we have taken all these formulas based on these CGS units. So gram atomic weight is how much, 55.85 gram, into bracket supply voltage 10 volt minus ore voltage 1.5 volt divided by density in grams per cc 7.86 into valency into Faraday's constant 96500 coulombs per mole into valency is 2 into feed rate. किसमें दिया feed rate? 1 mm per minute. Now 1 mm per minute, that is how much we want in centimeter per second, isn't it? So 1 millimeter, that is divided by 10 centimeter, that is 0.1 centimeter divided by second, that is 60, isn't it? So let us calculate this. That is 0.2 into 55.85 into 8.5 divided by 7.86 divided 96500 divided by 2 divided by 0.1 into 60. So it will be how much? 0.2 into 55.85 into 8.5 divided by 7.86 divided by 96500 divided by 2 divided by 0.1 into 60. So it will be 0.0375. So nearly I will take 0.04 centimeter. So this is our answer. So what is the equilibrium gap? कितना आया? 0.04 centimeter. Let me check. Yes, it is correct. 0.04 centimeter. So let us take the next question. See, in ECM process with the pure iron workpiece, a removal rate of 5 centimeter cube per minute is desired. Determine the current required. Okay, so here ECM process is there and we have to determine the value of current, and for iron the values for density, gram atomic weight and valence is given. So we know that the material removal rate, actually this removal rate, that is MRR, which is Q in the ECM given as this gram atomic weight into current divided by density of the anode, that is workpiece material, into F into Z. F is Faraday's constant and Z is the valency. So here Q value is given. Q is how much? 5 centimeter cube per minute, and we know we need the CGS unit. So Q I will write in terms of, say, 5 centimeter cube is okay, but divided by minute. So I have to take it into seconds. So 5 divided by 60, that is centimeter cube per second, is equal to A 56 into I is unknown divided by density 7.8 into F 96500, we should know the value, into valency. So if I calculate, what I'll get, let me calculate, that is 78 into 96500 divided by 60 divided by 56. So it is 2240.17. 2240.17, it is correct, 17 amperes. So this is the value of the current. This much current will required in this process. Okay, so dear student, let us discuss this last question on this electrochemical machining. So the surface irregularities of the electrodes are 5 micron and 8 micron. These are heights of the peaks of asperities as shown in the figure. If the work is pure iron and DC voltage of 12 volt is applied or employed, estimate the largest possible feed rate which can be used. In this case, take this conductivity of electrolyte K as 0.2 per ohm per centimeter and this ore voltage as 1.5 volt, and these properties for the iron are given as density 7.86 grams per cc, gram atomic weight 55.85 grams, and the valency as 2. So of course here are the peaks of asperities are given for the work surface and electrode surface, and we have seen this. In this case, what we have to take the nominal gap as, and this nominal gap is what? Allowable nominal gap between the two electrodes, that is work and tool, as what? The peak values of this work surface as well as from the tool surface. The summation of this, that is 8 micron plus this 5 micron, so that is 13 micron. So it is micron, so converted into centimeter, so it will be 0.00013 centimeter. Very simple, and that will be our what? The equilibrium gap, and this will be our equilibrium gap. And we know how to calculate this equilibrium gap. This YE is equal to K into A into bracket V minus delta V divided by rho FZ into this F. So here they are asking for this feed rate. Definitely feed rate in centimeter per second. So this feed rate we can write F is equal to this K is how much? This is 0.2 into A 55.85 into V minus delta V, that is supplied voltage is how much? 12 volt minus over voltage 1.5 volts divided by density 7.86 into F 96500 into valency 2 into equilibrium gap, which how much now? 0.00013 centimeter. Isn't it? So let us calculate and tell me the answer. So it will be into 0.2 into 55.85 divided by 96500 divided by 7.86 divided by 2 divided by 0.00013. So it will be 0.6 or 0.59. So please here it in centimeter it will be 0.0013. Please remember, oh, sorry, 0.0013 centimeter is there. Okay, so if we have this value, then feed rate will be 0. How much it is? 0.059 centimeter per second. Okay, if you want to convert it into mm per minute, then it will be 0.059. So 10 centimeter is equal to, sorry, 10 millimeter is equal to 1 centimeter. So into 10 millimeter into, for minute 60 minutes are there, into 60. So it will be in mm per minute. So this will be the feed rate if they are asking mm per minute. So how much it is? So into 60 into 10 is 35.68 mm per minute. So this will be the feed rate. Very simple. See how we have done it. Thank you so much.